Next part is to see if we can solve for distance by itself. To get rid of this divide by t, we have to multiply by t. We put a t here and a t there. Why on both sides? Well, think of an equation as a teeter-totter. Ty comes along, sits on this side of the teeter-totter. He will unbalance it. But if his twin brother, Tyrone, sits on the other side, it's balanced again. However, the whole point was to cancel out the t. So the multiplication of a time over time cancels out, and we are left with a solution of d is equal to v times t. Do not put the time on the left side. Don't leave it TV. One, it'll distract you. You'll be thinking about Netflix and all that kind of stuff. But it looks stupid. You ever seen a person eating a sandwich from the square end of the bread, or worse yet, from the side? How about someone eating a corn on the cob from the end, not the, length? It can be done, but it makes you look goofy. In science, we always put the time on the right side. It'll make things convenient. Please do so. Now let's take a look at a classic problem. Because the thing is, with that previous equation, okay, go back here for a moment, we're not certain that this equation is correct. Right? You've done it, but does it work? So I'm going to try another little thing here first. Let's go back to a classic math teacher problem. Things that math teachers think are practical. 7 equals 14 over x, solve for x. That's math, right? So your friends, you're sitting there at your desk going, well, what are we going to do? And you come up with these three possibilities. 7 divided by 14 is 14 times 7, or it's 14 divided by 7. And you're like, wow, which one could it be? So you come up with the brilliant plan of averaging these three, and you come up with an answer of 33.5, and you wind up concluding that you're no good at math. This kind of brute force, just let's try every possibility, worked for Thomas Edison and the light bulb. It doesn't work this way. Now, I'm hoping in this problem you could see by sheer inspection that 14 divided by what equals 7. This one you can solve in your head, and you can conclude that the solution for x would be that it's 14 over 7. You switch the two. But I don't want you to just get a gut feeling. You have to decide, is my approach correct? What if these two numbers were such that you couldn't possibly carry them out? Like, this isn't 7. This is like 7.9 times 10 to the 23. And this is 14.796321 times 10 to the 77th. Even your calculator might not be able to carry it out. So how can you prove that your approach was correct if you don't have the answer? I'm going to step one further. That's what we want to do with these equations. We think this was true. But it's quite possible when you rearrange that you came up with one of these two erroneous possibilities. How can we tell which rearranged formula is correct? How can you verify on your own for your own confidence rather than waiting to check with the teacher and then just concluding, oh, I was wrong, I'm no good at this? And this requires one more step forward before we get to that. What we need to do in physics is keep those dimensions. Now, what is called dimensional analysis is to look at these numbers with their dimensions and go, does this answer make sense in the real world? So the dimensions on these numbers, they are values of parameters taken from the world around you. They should make some degree of sense. The simplest means of checking is to use the units without any numbers in the formula and see if you get the dimensions correct. So a simple example, your archenemy, because I'm tired of them being friends, insists that the area of a circle is 2 pi r. You claim that the area of the circle is pi r squared. What's the solution? Obviously a physics knife fight. But since we're not allowed knives anymore, we have to solve this logically. So you take your archenemy and tell him to write down his formula. And you point out when you look at not the numbers, get the numbers out of there, the units, the square bracket means what is R being measured in? And the answer is it's measured in meters. So you have an equation that's measuring area in meters. That is not correct when we measure these concepts. This would be like saying I calculated the distance to Toronto and I got 80 cubic centimeters. The number, you don't know if it's right or wrong, but the concept is completely erroneous. So let's look at your possible solution. You claimed that this was the formula governing area. Take away the numbers, you claim that the dimensions are meters times meters, which gives you a unit of meters squared. These are the expected numbers, or expected units for area. So your formula is correct. No knife fight is required. And I'm going to pause it here because it's a logical spot and some students want some help.